When we're learning about foundation models, I think it's really important to understand the history, the context, and the story behind how we got to where we are today. So the agenda for this lesson is as follows. So we'll start at 1950s and go all the way to the ChatGPT moment and also the foundation models today, right? So I created this neat little timeline for us to help visualize all the important moments in the AI world. And let's take a quick flyover through it, right? So in 1950, Alan Turing, very famously known as father of theoretical computer science today, he was also he was a British computer scientist. He contributed to deciphering the Enigma code in World War II, which led to the Allies achieving victory sooner. But he also did a lot of work in AI as well, and we will see his work in defining the Turing test. Perceptrons, which are the rudimentary version of today's neural networks, we saw them in the 50s as well. We saw first chatbot in the 60s, work in backpropagation, which is a technique used in training these models. There was a report which came out in the 70s, which was a very critical assessment of state of AI. So everything that had been happening up until the point, it painted it in a negative light, and basically the mood was that AI was all about hype and overpromises rather than delivering things, which led to a lack of research activity and funding in AI. And in around late 80s and 90s, we saw things sort of explode again. You know, we saw the Deep Blue versus Kasparov moment when IBM's Deep Blue supercomputer beat the world chess champion Garry Kasparov. We saw the emergence of using GPUs for deep learning. We saw a lot of announcements in consumer world, Apple launching Siri, and also competing products by Google as well. And then finally, we see the transformers come about, and then models like BERT getting announced, and famously the ChatGPT moment all the way to today. So this is the timeline we're going to take a journey of in a little bit more of a depth than what I just did. And it's really interesting, and I think it's worth knowing. Right, so let's kick this off at 1950s, right? So during 1950s, AI was a very nascent idea, and in fact it hadn't even been formally coined yet, the term AI. So Alan Turing comes in, and there was a lot of activity and interest around the time about machines that could think and machines that have intelligence. All of these people had various different backgrounds, from information systems to philosophy to biology, who came together, who did research, not always together, but they thought about what it looked like for a machine to have intelligence. And Alan Turing had a famous paper called Computer Machinery and Intelligence, where he introduced the concept of Turing test. And during that time, the idea was to create a test which was basically you were talking to a human being or a computer through a window, through a written responses. This was the original test, and the idea was for the person see in this image to figure out whether they were talking to a human being or a computer. And the idea of this experiment was to define a test which could test whether machines truly had intelligence and could fool a human being into believing that they were a human being. It was a very notable moment, and as father of theoretical computer science, this was basically a starting point of discussion and interest, and it kicked off a lot of ideas in AI. And then the next thing worth noting happened in 1956, the summer of AI. This was when the term artificial intelligence formally got coined at Dartmouth College, which is a private Ivy League university in the United States. Some really famous minds of the time in information systems, in computer science, and various areas gathered, famously Claude Shannon, John McCarthy, Marvin Minsky, and Nathaniel Rochester. And the goal of this getting together, this workshop, was for to kick off research and to kick off interest and to also formally establish AI as a field of research. And it's also widely regarded as a point in time when AI was formally born as a discipline. And then we fast forward 2 more years to 1958, and this was when we saw Rosenblatt's version of perceptrons, and these are basically the building blocks of neural networks. These are the neurons which were meant to model a biological neuron in the brain, right? And what Rosenblatt was able to achieve in 1956 was a very simple classification where he was able to show a binary classification algorithm which could detect whether a dot was on the left side of a paper or the right side of the paper. And this was when there was a lot of excitement around perceptrons, and Rosenblatt says that perceptron is the first machine which is capable of having an original idea back in 56. This is really important because you can still see these perceptron and the ideas and the algorithm around it implemented in today's deep learning algorithms. After the 50s, in around 60s, there were a lot of work still going on, but there was reduced enthusiasm in the industry, and there was also reduced funding, and this was as a result of there being a lot of hype and a lot of promise around AI, but AI not being able to deliver any physical, tangible value to businesses and the government, which slowed down the research and development. Back in the day, the algorithms, the hardware, they were all rudimentary compared to today, which was also a limiting factor. As a result of this, not a lot of developments happened in AI during 70s and 80s. There was still some activity, but not as much as during 50s and what happened afterwards in 90s and 2000s. So after the AI winter, we go to late 80s and early 90s. Again, neural nets are back in focus. Hardware is now faster and cheaper. We also famously see Jan LeCun's LeNet, which is a image recognition model, which was able to basically understand numbers. And it was also rolled out to United States Postal Service to categorize the postcodes written in the envelopes for letter delivery, mail delivery. That was an actual case where models were able to reliably detect images and convert them into their numerical values, essentially OCR. And then in 1997, there was the famous moment when the world chess champion Garry Kasparov was defeated by IBM's Deep Blue in a rematch in 1997. So IBM's Deep Blue supercomputer was engineered by training it on chess strategy, move calculation, but it was essentially doing brute force search of the various moves it could take, and it beat the world chess champion, which was a big deal at the time, and it was also showing the promise of AI, what AI could do in specialized fields. And also complicated and fields where strategic reasoning and thinking is said to be important. All right, so now we are at the turn of the millennium, when we have seen a lot of activity from the 50s to the 2000s, except during the AI winter. And things actually started to kick off in 2000s and afterwards, as we are all aware of. So during the 2000s to 2010, there was a lot of work happening in neural nets, in deep learning, in convolutional neural nets. Geoffrey Hinton, who is said to be the founder of generative AI, had a paper where he basically did a literature review of all the work that was being done in deep learning. And he also proposed a model of deep learning where he suggested that, arranging your model's architecture in such certain way basically solved a problem of vanishing gradients, which was a limiting factor for training bigger and larger models with more compute and more data. There was also the ImageNet dataset, which famously was a dataset of millions of images of thousands of different categories, and it was used by a lot of different AI labs all over the world to train image classification models and basically pioneer ideas around computer vision. Sorry, let's go back. And then also another thing that happened in 2007, 2008 was there was a paper out of Stanford by Andrew Ng, which was about large-scale, deep, unsupervised learning using graphics processors. And this was when he suggested that using GPU acceleration for training deep neural networks sped things up by orders of magnitude. And it sort of popularized using GPU as a mainstream computing environment for doing deep learning neural network. 2012 was yet another notable moment, and this time because of AlexNet. AlexNet was a image classification model trained by using deep learning by Geoffrey Hinton and the team, and it wins the ImageNet competition in 2012 by a landslide. So we looked at ImageNet before. ImageNet is a data set of images, millions of images of thousands of different classes, and all of these images are labeled. And ImageNet challenge is basically a large-scale visual image recognition challenge, and there were a lot of different algorithms, a lot of different labs competing to beat this challenge. And AlexNet was really good, and it had a unexpected victory by using deep learning model. Because of this achievement by AlexNet at the ImageNet challenge, there was a lot of interest in deep learning, and it sparked a lot more innovation and interest in the area. Another notable moment came in 2016. This was another victory for deep learning, and this time the game of Go, which was for a long time thought to be impossible for computers to beat humans at, just because of the complexity and the strategic thinking required for the game, and also the vast possible states or different permutations and combinations that the game board could take at a given time. Because of that, the technique that Deep Blue, IBM supercomputer, used to beat Garry Kasparov at chess wouldn't work. It was using brute force, and here AlphaGo used Monte Carlo tree search to reduce the search space. It also was trained by using deep reinforcement learning, and the result was a victory 4-1 against Lee Sedol, who was the world champion at the time. And it captured everybody's imagination. Half of the people were very optimistic about AI and what this meant, and other half were scared because it was also the moment where we proved that AI could beat humans at Go, which was thought impossible for a long time. Another important thing to note here is AlphaZero in 2017 again. This was another model that came out of Google, which was even better than the model that beat Lee Sedol. And the surprising part about it was trained orders of magnitude cheaper, faster, using reinforcement learning. And finally, we move on to 2017 when Transformers paper came out. Attention is all you need is the paper that came out of Google Brain team. In the next lesson, we will look at a training of how a Transformers architecture model is done. But here on a very high level, Transformers were able to achieve state-of-the-art performance for natural language processing tasks compared to RNNs or LSTMs, which were quite popular for the task at the time. The key innovation behind Transformers were attention mechanism and also the fact that it made it possible to massively parallelize the training and inference of the model in huge clusters of hardware. An important thing to note with the attention is all you need paper is also BERT, which was one of the first model trained in the Transformers architecture, and it was trained on massive amount of data, and it was used for various different NLP use cases. Personally, myself, I have also used BERT models for sentiment analysis use case as well. So just to give you an idea of how the BERT model, one of the first transformer models that came out of Google, compares in size compared to today's model. BERT came in two sizes, BERT base and BERT large. The small model had 110 million parameters. The big one had 340 million parameters, right? And they were also trained on 800 million words of text from thousands of books and 2.5 million words from English Wikipedia. And for a long time, BERT models were a really good foundation to build custom natural language processing models on top of. And then suddenly it's 2022. This is the ChatGPT moment, which captures the internet by the storm. Everybody can now access GPT 3.5 model through a simple chatbot interface, and everybody's minds are blown, right? So ChatGPT, the T stands for Transformers, GPT generative pre-trained transformer. We will understand what the GPT means in another lesson. It's like BERT, but much larger by orders of magnitude. It was trained on much more bigger scale of corpus of data for a longer amount of time in a bigger hardware. What it meant was that it brought AI to the masses. Everybody could now see the impacts of AI and what these transformer models could do. There was a lot of funding, interest, buzz about AI, and also it sort of kicked off the foundation model boom, the agentic AI boom that we see today in 2025. So today we have heaps and heaps of large pre-trained models from various different providers. Depending on what your appetite is, you have lots of state-of-the-art model providers, from OpenAI to Anthropic to xAI with their latest Grok 3 model that came out yesterday. And also a lot of multi-modal models. Multi-modal models are a category of foundation models which work on different modalities of data. So whether it be text, image, speech, it can natively understand those modalities of data and respond in those modalities of data. Examples include GPT-4o, Gemini, and others. So we have arrived at the end of this lecture. Almost. So the key parameters, as you can see, of these foundation models today they comprise of billions or trillions of parameters even. They're trained on huge corpus of data on huge amount of compute. And it's not possible for a private individual or even small labs to compete because of the just sheer size of electricity, the graphical computing, and the data set that you need access to in order to train these foundation models. So we have arrived at the end of this lesson. I hope you found this journey from 1950s with the Turing test all the way to today with the foundation models to be interesting. I think certainly the foundation models of today definitely passes and in way surpasses the Turing test as envisioned by Alan Turing in 1950. I will see you in the next lesson where we will take a deep dive into models like ChatGPT, transformer-based models, and how they're trained and how they work. Thank you.